Hi everyone, this lesson is for geometry students, chapter 2, day 3 of angle relationships and areas of triangles. So today we are going to be going over, or our learning targets for today are learning converses of some of the angle theorems, also try to do some geometric sense of length and area, and how to find the area of a triangle and some other shapes that we're going to be talking about. There are some videos to watch, also proof by contradiction, a video on triangle, angle, sum theorem, and also multiplying binomials, all of which we started to do last week. And if you had a little bit of trouble with that, here's some additional videos that you can watch. So we're going to get started with a warm-up solving for x and y. And so in doing this, we know we do have parallel lines. And as you know, I personally do like to draw in my parallel lines. I do think that that's super helpful, and also extending them. I think that that's also important, so that it does help. Meaning, the reason is because, like, for example, if let's say this is 70, that's 70 also, because those are alternate interior angles and they're congruent because there's a parallel line cut by this transversal. Additionally, x would be 7 because those are vertical angles. This would be 50, it doesn't have a value, but I also know that this plus this would equal 180. And so 70, so you can either go 70 plus 50 plus y is equal to 180, right? And so you basically would go 180, subtract 70, subtract 50, and I get 60. So that means y is equal to 60 degrees. That would be this value here. Okay. For these two problems here, this one I want to find x, y, and z. This one I just want to find x and y. So for the one on the left, let's see. I know that this is a 90-degree angle, which means this other two sums have to be 90. So if that's 40, that's 50. I know that this angle here and this angle here are congruent because of these two lines being parallel, cut by that transversal. I can say that z plus 10 equals 50, so z equals 40. So I do know that equals 40. I know that this angle here, I could do a couple of different things. For one, I can say this plus this equals 180, which means that if I said 180 minus 50, that leaves me 130. That angle right there has to be 130 degrees. So if I said 2x equals 130, so then x would actually equal half of 130. What would that be? 65. So we have 65. X is 65. The angle, though, is 130. And then this would be 130, and then that would be 50. So y is 50, x is 65, and z, what was z? What was this? Z was, I think that was 40. I lost my values here. Okay. For the right problem here, these look like alternate interior angles for sure. So we know that this plus this, so we know that x, let me write this out, x plus y equals 60. And this and this are alternate interior angles because of this parallel line, right? So that means that x minus y is equal to 46. So x minus y equals 46. Now this is a system of two I have got a system of two unknowns, right? Two equations, two unknowns. Multiple ways of solving this: graphing method, elimination. There's a couple of other ways. One's called Kramer's rule. We'll probably learn that next year, or we could probably show you this year too. But also, what am I missing? Substitution. So decide how you want to solve this. I'm just going to add these two equations together, and that's elimination, because my y's are going to cancel. And I end up getting 2x is equal to 106. And then when I divide both sides by 2, let's see if I can move this down a little bit. When I divide both sides by 2 on here and here, I'm going to get 53. So x is equal to 53. So what that means is, in order to figure out how to what the other value is for y. I need to plug 53 in for x into one of my equations. So I'm just going to choose this top one, which says x plus y equals 60, and I'm going to plug the value for x in here. So I have 53 plus y is equal to 60. Subtract 53 from both sides, and I get y is equal to 7. So I've solved both of those values. Again, parallel lines. It says, what value of x would make these lines parallel? Well, these would be parallel if they were alternate interior angles and if the angles were equal to each other. So I need to find x, plug it back in, make sure that the equations work, and then see if that's accurate. So if they were alternate interior angles, those would be congruent. I would get the equation 3x plus 10 equals 5x minus 10. I'm going to subtract 3x. I'm going to get 2x on this side. I'm going to add 10. I'm going to get 20 on that side. I'm going to divide by 2. I get x equals 10. So in this equation right here, if x was 10, that would be 3 times 10, which is 30 plus 10, which would be 40. If x was 10 here, 50 minus 10 would give me 40. So therefore, this is how you write therefore, by the way. Therefore, x equals 10, and j is parallel to k, and you would say because they're looking for the justification, right? Because the alternate interior angles are congruent. That's the reason. For this one, if JK was parallel to, if J was parallel to K, then these two angles inside, that one and this one, are what we call same side interior angles. And that means that they would be supplementary. So that means that 6x plus 5x add 15 would add up to be 180 degrees. So 11x add 15 equals 180. So I'm going to use my calculator. First, I'm just going to subtract 180 minus 15. I get 165 equals 11x. And then I'm going to divide 165 by 11. And I get 15. So x equals 15. So if these are same side interior angles, then those angles, they're not going to be congruent. They are going to be supplementary. So let's check. So if you take 15 and you multiply by 6, right, you should get 90, which means this would be 90. And then if I said 15 times 5, that's 75. That's 75. Add 15, right, 7, 8, 9. This also would be 90 degrees. So because these two angles are supplementary, they would be, J is parallel. So you would say, this is what you would say. J is parallel to K because the same side interior angles are supplementary. And then you would state that. For these ones also, what would make J and K parallel? Again, first of all, I know this is 90, which makes that 90, which makes that 90, and what makes that 90. And which means that this angle has to equal this angle because those would be alternate interior angles. That's option 1. Option 2, I can say this angle is equal to this angle because they're corresponding angles. So let's just say that. 2x minus 10 equals 90. Add 10. 2x equals 100. X equals 50. So let's check. 50 times 2 is 100. 100 minus 10 would be 90. There's supplementary. Those are congruent. Those are congruent alternate interior angles. So like so x equals 50, yes. But we have a multitude of ways that we would state the justification. You could say these top angles are congruent and therefore J is parallel to K because corresponding angles are congruent. You could say that. For this one, these are very specific in that they are not congruent because they're both inside. If J was parallel to K, then these would be same side interior angles. And again, same side interior angles add up to equal 180 degrees. So let's write that out. 3x plus 8 plus 7x minus 8 equals 180 degrees. Add your x's up. We've got 7x and 3x, which is 10x. 8's are going to actually cancel. I get 10x equals 180. Therefore, x is equal to 18. Now, if this is true, and if these are same side interior angles, they would need to be supplementary. So let's plug in 18 and see if that actually works. So we're going to go 3 times 18, which is 54, add 8, and I get 62. Okay, so this one, I'm going to go 18 times 7, which is, 126, and I'm going to subtract 8, and I get 118. And so I would add 118 plus 62. Does that equal to 180? It does. Therefore, x equals 18, and J is parallel to K because the same side interior angles are supplementary. That's how you say it. That's, okay. Again, for this one is a little bit tricky. Again, what would make those two lines parallel? Why don't we just use J and K since we've been using that for, the last several problems. If J is parallel to K, then these lines would be supplementary, which would mean x squared plus 3x equals 180. Now, this is a little bit different because this is a quadratic. What that means is if you have a squared value, you need to set your equation. That means like the very first thing you need to do is set your equation equal to 0. So you've got x squared plus 3x minus 180 is equal to 0. So if that's the case, so what I would do now is either A, use quadratic formula, or B, try to factor that. So I'm going to try to factor that. What times what is equal to 180? Well, I know x times x equals x squared. My signs to get a minus sign here would be one's positive and one's negative. Now the rest, the obvious question would be like 18 times 10. But remember, I have to make the difference of those two has to be 3. So I'm going to try to think of a higher number. So I'm going to try 15. 180 divided by 15 is 12, which means that 15 times 12 is 180, check, and there's a difference of 3 here. So what I want to do is I want to look at this and I want to say, well, this is a positive 3. So that means this is going to be a higher number, 15, and that'll be 12. I'm going to split this up. I'm going to say x minus 12 equals 0, so x equals 12. I'm going to go x plus 15 equals 0, so x equals negative 15. Now, I can't use x equals negative 15 for these reasons. For this angle right here, this totally fine because negative 15 times negative 15 is 225. However, check this out. That's more than the actual sum of the two angles. So not only does that not make sense, but also the fact that x can't equal negative 15 because this would be 3 times negative 15, which would give me a negative 45 angle. Not happening. So that means x is equal to 12. And let's check, just for sure, let's check, because it says for justification, 3 times 12 would be 48, and then 12 squared is 144. That's 12 times 12. And if I go on the side and I go, well, what's 144 plus 48? Let's see. 8 and 4 is 2. Is that right? 144, 12 times 12. That's 8. Hold on a second. 9. That's 192. That just can't be true, can it? Oh, I know why it's not true. Because 12 times 3 is not 48. Hello. That's 12 times 12 is 144 for sure. But 3 times 12 is 36. Yes. So definitely not 48. So if I go 144 plus 36 and I get 4, 5, 6, 7, 8, 180, check. Therefore, J is parallel to K. The reason is that these two angles here are same side interior angles. this is an auxiliary line. And an auxiliary line is a line or array, segment or array that's added to a diagram that, like, you just add that in to help you solve the problem. Okay, so let's do that. What we have is this equation, and notice that the question is to find angle 5, which is this angle out here. I mean, like, that's my goal. The measure of angle 5. I'm going to put this out here so I don't, like, forget it. What I also know is that these two lines are parallel. However, if I drew in my auxiliary line, which I'm going to do right here, and say that this line right here is parallel to these two other lines. Therefore, if those are parallel, right, these are parallel, therefore I have same side interior angles, alternate interior angles, congruent, all that. So meaning if this is 80, this is 80, because those are alternate interior angles. Likewise, if this is 140, this would be 40 because those are same side interior angles, which add up to be 180. So what's happening now is they want the measure of angle 5, which is 40 plus 80, which is 120 degrees. Right on. Cool. Okay. Oops. Don't know why that's there. So then we have something called the triangle exterior angle theorem. This is very important. It means that the measure of angle 1 equals this angle right here, the sum of the two remote interior angles. Remote meaning away from, not next to, but away, remote. So meaning this angle here would be next to. That's not the angle. I don't want that one. They're saying angle 1 is equal to the sum of the two remote interior, meaning inside. So that's saying the measure of angle 2 plus the measure of angle 3. So that's what the exterior angle theorem says. That's very important because, for example, if I said this was 100 and this was 20, well, this would have to be 80 because 80 plus 20 equals 100. The sum of one exterior angle is equal to the sum of the two remote interior angles. So very important theorem. Additionally, this is, we were all talking about triangle angle sum theorems yesterday. These right here, if you see these angles that are not the same, 1 slash and 2 slashes, that means they're not congruent. Okay? It says, but what they're saying is if this angle here is congruent to this angle here, and this angle is congruent to this angle, then that leaves this angle C congruent to angle Y. So basically, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So that's one of the corollaries. And then on this one, it says each angle of an equilateral triangle has a measure of 60 degrees because the sum of the angles of a triangle add up to be 180. However, if you divide that by 3, because if you notice that the sides are all congruent, which means that my angles are all congruent, just 180 divided by 3 is just 60 degrees. Another corollary for triangle angles is that in a triangle there can be at most, so that should be at most, meaning you can't have two right angles in a triangle. And you can't have two obtuse angles in a triangle. I mean, try to imagine drawing that. So, like, here's an obtuse angle, there's an obtuse angle. Definitely not a triangle anymore, right? Corollary 4 states the acute angles of a right triangle, meaning if this, we know that's 90 degrees, that means that this angle plus this angle must also equal 90 degrees. And something very cool is that if this is an isosceles right triangle, right, where that angle and that angle have to be add up to be 90, but if it was isosceles, it means that two sides are congruent, which means my angles are congruent, and therefore each of those angles is 45 degrees. So if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So we've got something called a converse. And so that's a word, definitely a vocabulary word you do need to know. The converse is if you have your hypothesis and your conclusion, right? If two parallel lines are cut by a transversal, then the corresponding angles are congruent. The converse just takes these two values and flips them. And now my hypothesis is now my conclusion, and my conclusion is now my hypothesis. So it says, if two parallel lines are cut by a transversal, then the corresponding angles are congruent. The converse says, if the two corresponding angles are congruent, then the lines are parallel. The converse of the next one says, if two parallel lines are cut by a transversal, alternate interior angles are congruent. If two lines are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. Likewise, if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. If the same side interior angles are supplementary, then the two lines are parallel. So this is what we call the converse. It just, like I said, hypothesis and conclusion become conclusion and hypothesis. We went over these values here last week, just classifying triangles and sides. I just want to reiterate what we talked about, and that was, if you have an equilateral triangle, all three sides are congruent. If all three sides are congruent, then all three angles are congruent. And then, therefore, all three angles are actually 60 degrees. For an acute triangle, all three angles are less than 90 degrees. A right triangle has one angle. We'll just call it XO. It has one angle equal to 90, and then an obtuse triangle has one angle greater than 90, and definitely not equal to 90, right? Because if it was equal to 90, then it would be a right triangle. If it was less than 90, it would be an acute triangle. Now, an isosceles triangle has two sides congruent. Therefore, my base angles are also congruent. Okay. And then this angle way up here at the top, remember, we call that the vertex angle. Okay. Scalene triangle means all three sides are different lengths. And if all three sides of my triangle are different lengths, that means that all three angles also have different measures. So we're moving on to what we're talking about is perimeter and area. And our question for this problem here is to find the perimeter and area of this blue figure. And so what I would do, there's two things. Number one, you do need to know what the perimeter, how to find the perimeter of a shape. And that's just basically adding all the sides around. And then area is that space inside. Now, the area of a rectangle is base times height, or length times width. The area of a triangle is equal to 1/2 base times height. However, and because it's half of a rectangle, right? So it's half that base times height. However, there is some stipulation for the area of a triangle, which is actually really important. So I'm going to rewrite that. The area of a triangle is equal to 1/2 base times height, like I just said. However, the base must be perpendicular to the height. Those are the two values that I want, because a lot of times in a triangle, they're going to give you additional information, and you don't necessarily need all that information. You just need the base and the height, but they have to be perpendicular. So to find the perimeter, let's see what we got. We know that's 8, so this is 8. Being a rectangle, they both have to be the same. So 8 times 12. Now, here's the thing with this. There's like this little piece cut out, right? And in order to find like this side of the triangle, let's see what we got. We know this is 12, right? And if that's 12 and that's 8, this must be 4. Okay. So that means that I could find the area of that outside, right? And not include that. We're going to come back to that for just a second, because we want to find the perimeter first, right? So the perimeter is going to be 8 plus, so we're going to go, we've got 8 plus 12 plus 8 plus, and I'm just going around. Oh, I don't have this value. Let's come back to that. Plus whatever that value is, plus 6, plus 3, plus 5. Okay, so now in order to find this length right here, actually, I'm going to need to use something called Pythagorean theorem. And you may or may not have done this before. The Pythagorean theorem says if I have a right triangle, then the square of the first side plus the square of the second side is equal to the square of the third side. Oops, 2, not 3. All right, so that means that 36 plus 64, that's 0, 1, 6, 7, 8, 9, 10, is equal to x squared. So x is going to be 10. And keep in mind, I think a lot of you have actually seen triangles that have these values. Look for them: 6, 8, 10, 3, 4, 5. You see that? Those are values. Just keep that in mind for just a second. Actually, the 3, 4, 5 is the 6, 8, 10 divided by 2. Anyway, let's still find the perimeter. What we have, it looks like, is we have 12 plus 8, 20, plus 8, 28. So we know this is 28. And then I believe this was a 10. So 28 plus 10, that's 38. And what did we say? We said 6 plus 3, that's 9, plus 5 is 14. So we're adding 38 and 14. So that's going to be 42. And you've got to be able to choose the units, meaning some of the units are like feet, inches, meters, whatever, kilometers. If you don't see any values like any units described, you can just say U for units. Because I'm finding the perimeter, I'm just adding a unit plus a unit plus a unit. These are just units. And so that's my answer for the perimeter. For the area now, I need to think about the space inside. And so in doing that, I need to think about, well, I need this rectangle plus this triangle minus this little rectangle, or that little triangle, right? So the area of a triangle, right, is 1/2 base times height. We were just talking about that, where the base and the height are perpendicular. Notice they are. So 1/2 my base times my height. So 1/2 of 8 is 4. 4 times 6 is 24. So far that's 24. To find the area of this little triangle here, this is going to be 1/2 my base. Oh, and we knew that the height was 4, right? We found that out, 3, 4, 5. Okay, so 1/2 the base times the height. So that's 1/2 of 4, which is 2. 2 times 3 is 6. So this space inside is 6. And then the area of the whole rectangle, right, is 12, what is that? 12 times 8, 196? Okay, so basically we're taking 96 units squared, because that's units times units, 24 units squared, units times units, and 6 units squared. So we're going to go the area of the rectangle minus this little triangular area plus this triangle. So we've got 96 minus 6 plus 24. How many is that? 96 minus 6 is 90. 90 plus 24, 9, 10, 11 is 114. And if I'm adding unit squared plus unit squared plus unit squared, it's 114 units squared. All right. So I want to make sure that you guys understand something though too, which is this is really important. And that is if two figures are congruent and then they have the same area. So like if I said that this triangle is exactly the same as this triangle, everything in this triangle is the same as that triangle. These triangles are congruent because everything on the left side is equal to the right side. Then those two shapes then have the same area. However, if two figures have the same area, that does not necessarily mean that they are congruent. Because I can have a circle that has an area of a value that does not equal the same value as this rectangle, but they have the same numbers somehow, okay? So those aren't exactly the same. And maybe even a better example would be maybe A triangle could not be the same as a rectangle. So the three formulas that we're going to be using today mostly are triangle, parallelogram, and maybe a trapezoid. We've got the triangle formula is 1/2 base times height. Again, I want you to add that the base must be perpendicular to the height, like that. See that? Additionally, the area of a parallelogram also is base times height, but most important is that the base is perpendicular to the height. Because in a parallelogram especially, they're going to give you additional information. They might give you that's 5, that's 10, that's going to be 10, that's 7. What do you use? Which is the base, which is the height? What if I turned it sideways? Okay, I don't have a height then. So if I have this like this, my base is 10 and my height is 5 because they're perpendicular. Okay, so you've got to think about what is going to make your shape have that perpendicular line. And if it doesn't, then you actually have to find that. For a trapezoid, this one's a little bit different. Yes, the base and the height are perpendicular, but I actually have two bases, right? Same as this, but anyway, they're different lengths. So for this value, some people write 1/2 the sum of the bases, base 1 plus base 2, base 1 plus base 2, and then times the height. For me, I prefer to say the area of a trapezoid is equal to the height divided by 2 times the sum of the bases. So that's how I actually write the formula for that. So again, area of a rectangle, we already know if it's a rectangle, the base and the height are perpendicular. So the area, and so just you're going to write these down and you're going to have a list on the side and just keep adding to your list. The area of a rectangle is base times height. And again, we already know that the base and the height are perpendicular because it's a rectangle. Area of a square, same thing. So the area of a square is equal to side times side, base times height, right? Which they happen to be the same value. That's why they're using the same letter. And therefore, the area of a square is side squared. So if this was 10, this would be 10 times 10, which would be 100 units squared. If this was a 5, this would be 5 times 5, or 25 units squared. So that's how we write the area. Area of a parallelogram, again, so again, so important that you understand that the area of a parallelogram is the base times height, where the base is perpendicular to the height. So you have to know that. Likewise, area of a triangle is going to be equal to 1/2 base times height, where the base is perpendicular to the height. Area of a rhombus is a little bit different, okay? The area of a rhombus is equal to 1/2 the first diagonal times the second diagonal. That's really important because we also know that diagonals are perpendicular in a rhombus. So that's diagonal 1 times diagonal 2 divided by 2. And this is a proof for that, and we'll show you that in class. And so basically, if I told you, now this is a little bit tricky, that an isosceles triangle has sides 5, 5, and 8. What is the length of that altitude? And an altitude is a height. What's the length of that altitude? Now, two things. Number one, you should recognize that if this is 8, and this being isosceles, that's very symmetrical, meaning this whole thing is 8, that would be 4, and that would be 4, which would mean that this would be 3, because I would use the Pythagorean theorem that said 3 squared plus 4 squared is equal to 5 squared, or 3 would have been x squared, right? So 25 minus 16 is 9, and so x squared equals 9, which means x equals 3, which is my height. So we have the length of the altitude. The length of the altitude equals 3. So now what I need is the area of the triangle. So the area of the triangle is going to be 1/2 my base times my height. But remember, my base has to be perpendicular to my height. So it's going to be 1/2 the base, which is 8, not 4. You got to be careful with that. Times the height, which is 3. So the area of my triangle is going to be half of 8 is 4. 4 times 3 is 12. And remember, area is always going to be units squared. So what we're going to do right now is we're going to play this little game called Who Wants to Be a Millionaire? And we're going to be looking for area and or perimeter for each of the problems. So the first question is asking us, what is the perimeter of a square that has a side length of 12? So if we have a square, let's say that's my square, one side is 12. That means if it's a square, all 4 sides are congruent. So that's 12. And so the area of a square is equal to 12 times 12, which is 144. A is our answer. Next question says the rectangle has a base length of 5 root 3. So rectangle's base is 5 root 3. The height is 2 root 3. So find the area. So the area of a rectangle is base times height. So it's going to be 5 root 3 times 2 root 3. Now what you need to remember is that numbers get multiplied with numbers and roots get multiplied with roots. So 5 times 2 is 10. So the area of my rectangle is 10 times. And then root 3 times root 3 is going to be square root of 9. The square root of 9 is 3. So this is 10 times 3. 10 times 3 is 30. Now keep in mind, these are units times units, so it is units squared. So D is my answer. What is the maximum area of a quadrilateral, which is a 4-sided shape, that has an area or a perimeter of 20? So you have to think about, what are my different possibilities? You try to think what it could be the maximum area for some, what do we know? 20. So we could say, we can't say 10 and 10, right? Because that would be my max perimeter. So then you've got to think about, well, what if this was 5, 10, 15, 20? 5 times 5, that would be 25. Okay, 25 units squared. What if I had 8, and then, what's that, 16? So that would be 2 and 2. Well, that's 16, definitely not. Let's see. What if I had, let's see, what could I use for 25? I mean, it can't be 10, so let's use 9, and 9, that's 18, and then that would be 9, very small. So let's try a higher number. Let's say this is 4, and this is 4, so that's 8. This would be 6, and that would be 6, so that would be 24. So it looks like my max area would have to be 25. What is the area of this figure? Now you guys can cut this up as you like, because I mean, some people are going to cut this up into 2 long rectangles and a little rectangle. Some people are going to cut this up like this, and they're going to go, this looks like little squares like that. Okay, so you've got to figure out, how do you want to split this up? I'm going to do it the other way, where the first time I did that, or the first time I cut it, was like this. And so realistically, we have this big rectangle. So our plan of action is to go the area of the tall one, area of the little one, and the area of the tall one, which could be 2 areas of the tall ones, right? So 3 times 11 is 33. So both of these are going to be 33. What I need to know is this little area in this middle. So, well, that's 4 and that's 4, but what is this length? Well, let's see. This is 4, that's 8. And if the whole length is 11, this must be 3. So the area of this little shape in here is going to be 12. So we've got 33 plus 33 plus 12. What is that? 66 plus 12, 8, 78. And there we are. The length of a rectangle is 3 times as long as it is wide. So I'm going to make a rectangle. I'm not sure how wide it is, but I know that the length is 3 times the width. So whatever my width is, my length is 3 times that value. Now, it also says that if the area is 54 centimeters squared, so that's saying that the area is equal to length times width, base times height. So we already know that W times 3W is my area. So that means my area is 54. And so what I would do is I would go, well, what's 54 times 3? So let's see, 12, 5 times 3 is 15, 1, 62. Oh, hold on one second. I just messed up on that. That's completely wrong. Sorry about that. 3W, so I should just do this. 3W squared equals 54. And then in order to find what W is, I'm going to go W squared equals 54. So I'm going to go 54 divided by 3, which is 18. Now, the width is W squared, right? Width. So to find W, or to isolate the W, I'm going to need to square root both sides. So W equals the square root of 18. Now, the square root of 18 is not a perfect square, but it actually does have a perfect square in it, like the square root of 9 times the square root of 2. Well, the square root of 9 is 3. So that's 3 root 2, which means that my width is 3 root 2. And it also means that my length is 3 times that value. So that's going to be 3 times that value. So 3 times 3 root 2. Remember, numbers get multiplied with numbers and roots get multiplied with roots. So this is actually 9 root 2. So this value is 9 root 2. Now notice that the question that they asked is what's the perimeter, which means I actually have to add all the values around. So I'm going to go 9 root 2 plus 9 root 2 plus 3 root 2 plus 3 root 2. So that's 9 and 9 is 18, and 18 plus 6 is 24. So my answer should be 24 root 2 is equal to my perimeter, and there it is. The next value says the length of a rectangle is x plus 3, so here it is. And we know that the area is this big length, x squared minus x minus 12. So what's the height? This is what we don't know, h. So what you're going to do here is you know that the area of the rectangle is equal to the length, base times the height. So my base, which is this value here, x plus 3, times my height. And I also actually know my area. So that means that I'm going to replace the area, with this value, which is what they told me was my area. So x squared minus x minus 12. So in order to get the height, or solve by the height, I'm going to take this value, x squared minus x minus 12, and divide that by x plus 3. And that's going to equal my height. So now what I'm going to do is I'm going to need a factor, actually. And this factors, let's see, x times x is x squared. To get negative 12, my options are 1 times 12, 2 times 6, and 3 times 4. So which one of those is going to give me a difference of negative 1? And that's going to be 3 times 4, but it's negative. So that means it's going to be a negative 4 and a plus 3. Now, that being the case, I've got x minus 4 times x plus 3 divided by x plus 3. My x plus 3's as a quantity are going to cancel. And so therefore, my height is equal to x minus 4. So this is my value, x minus 4. And if you want to check also to see if your answer is correct, you can also go x minus 4 times x plus 3 and multiply those out using the FOIL method, and that's going to give you that inside value. Find the area of the trapezoid. Now, we actually haven't given you the area of the trapezoid. I did give you the area, but we didn't do any practice problems. This is my height right here. Remember, the height has to be perpendicular with the base. The formula for the area of a trapezoid is height divided by 2 times the sum of the bases. So we're going to leave the height blank for just a second. I know that the bases are 6 plus 12. Now, what I do know is that if this whole length is 12, right? And this length here, don't know that either, but I know that this length is 6. So from here to here is 6, which means that the rest, there's another 6 missing if that was 12. So that would be 3 and that would be 3. And remember, we use Pythagorean theorem, which is 3 squared plus I don't know squared equals 5 squared. So 3 squared plus x squared equals 5 squared. So x squared equals 25 minus 9, which is 16. X squared equals 16, which means x is 4, which means my height's 4. So the area of my trapezoid is 4 divided by 2, 2, times 12 plus 6, which is 18. 2 times 18 being my area of the trapezoid, 36. The next question says, find the area of an equilateral triangle. Now, this problem right here is an equilateral triangle. All the sides are the same, which means that it says the perimeter is 18, which if the perimeter is 18, 18 divided by 3 is 6. So all these 3 sides are 6. Now, that being said, remember, equilateral means these are symmetric, which means this would be 3. So if I wanted to find my actual height, I can go height squared, side squared times side squared. So height squared plus 3 squared is equal to the hypotenuse squared. So the height squared is equal to 36 minus 9. 36 minus 9 is going to be what? 27 is equal to h squared. And then I'm going to square root both sides to get h by itself. So we're going to have the square root of 9 times the square root of 3. Square root of 9 is 3. So my height is 3 root 3. Now be careful. We just found the height, right? And so if my height is 3 root 3, the area of a triangle is going to be 1/2 my base times the height. But remember, my base has to be perpendicular to my height. So 1/2 my base, which is 6, right? That's the base, not 3, but 6, times my height, which is 3 root 3. And again, numbers get multiplied with numbers. And like so on. So 2 gets divided into 6 3 times. 3 times 3 is 9. 9 times root 3 is 9 root 3. And so that's the area of the triangle. We have the area of the figure shown below. This is a, looks like a rectangle and a triangle. So the area of the rectangle is 4 times 8, which is 32. The area of the triangle, remember, is going to have to be base times height, but it's half. So it's going to be 1/2 my base times the height. So 1/2 8 times the height, don't know what that is, plus the base times the height, which is 4 times 8. So we know that that's 32. What we need is this height. If this is 8, that's 4. And remember, in the last triangle, this is a 3, 4, 5. So it's going to be 1/2 my base times my height plus my area of my rectangle. So 2 divides into 8 4 times. 4 times 3 is 12. 12 plus 32 is going to be 44, and therefore that's the area of that figure shown. Find the area of a rhombus. Now I gave you the formula for that. A rhombus has 4 sides that are congruent, and it's telling me that the area of my rhombus is 100. So remember the formula. The area is 1/2 the first diagonal times the second diagonal. So if I drew in my diagonals like this, then what I have is the area, which is 100, equals 1/2 the first diagonal. And what does it say? The length of the one is twice as long as the other. So if one is x, then the other is 2x. And so 2's cancel. Looks like I have x squared is equal to 100, which means x equals the square root of 100, which is 10. The question is, find the length of the 2 diagonals. One is 10, and then the other one is twice that, so the other diagonal has to be 20. A square is inscribed in a circle. The circle has a radius of 4, which basically means that my length of my diagonal in my square is going to be 4 plus 4, or 8. So what they're asking me is that, what is the area of this square? Well, the area of a square is side squared, but we don't know the side, but we do know these sides are equal. So we're going to go x squared plus x squared is equal to 8 squared. 2x squared equals 64. Divide by 2. We have x squared is equal to 32. And I need to square root both sides. And in square rooting both sides, so what is the area of the square? Let's see, the radius is 4, which means that's 8. So therefore that's x. X squared plus x squared is 8 squared. 2x squared equals 64. Divide by 2, I get 32. Square root both sides. Now that's going to be the square root of 16 times the square root of 2. I get 4 root 2 as being this length. Now that's not an answer, but also that wasn't the question. The question wasn't what's x, because x is one of my sides. They want to know what the whole area is. So if I know that one of the sides is 4 root 2, that's going to be 4 root 2 times 4 root 2, which is numbers get multiplied by numbers. So 4 times 4 is 16. And then root 2 times root 2 is root 4. Square root of 4 is 2. 2 times 16 is 32. There we go. And so that's where we're at for the end of area for the problems that we know so far. There are systems of equations, and for this problem here, what I would expect that you do is when you see 2 equations and 2 unknowns, your job is to actually try to find the intersection point. And we're going to just do one of these by the graphing method, and that's solving for y. So I've got negative 2x, add 5. And then the other one, which is one equation, I'm going to box that up. And then my other equation, negative 2y equals negative 3x plus 4. I'm going to divide everything by negative 2. And I'm going to get y is equal to 3 over 2x minus 2. So I'm going to box up my second equation. So therefore, when I'm working this out, I've got 5. I start at 5. And then my slope, hold on 1 second. Let me make sure I do have 5. So 1, 2, 3, 4, 5. And then my slope is negative 2, down 2 over 1, down 2 over 1, down 2 over 1. And so this is my slope, or my line that has the slope of negative 2. Now this one actually starts at negative 2 and then goes up 1, 2, 3 over 2. And lo and behold, we found our intersection point as 2, 1. Now, in some of the problems, like we were doing yesterday, you were having to use parallel lines, right, cut by transversal, and then you had to find alternate interior angles congruent. You had to find, all different kinds of things. And some of the problems actually gave us 2 equations. Now, this is definitely one way I could solve the problem and to try to find the intersection point. But another way is actually to take the original equation and even look at the top. If I wanted to solve this by elimination, I would multiply the top equation by 2. And what I would do then is, of course, I'd have 4x plus 2y equals 10. And then 3x minus 2y equals 4. And when I added those together, I got 7x equals 14, x equals 2, right? There's my 2. And then I would plug it back into one of the equations, negative 4 plus 5, which is 1. So there's a bunch of different ways to solve these equations, but what you basically need to remember is that you are looking for an x and a y, not just one value, but you need to solve for both. So there's a couple of equations that you could do more for practice and with elimination, etc. And I'd like you to think about doing those. Tonight is your $1 million, like we were playing the $1 million game, right? But tonight is your homework, which is actually 3 different sections. So a little bit more than we're used to, but I do want you to practice doing these assignments. I wouldn't mind doing one more problem, and that would be maybe this one and solve by substitution, which we haven't done yet. And so if I were going to solve this by substitution means we're not adding and subtracting, right, to eliminate one of the variables. We're actually solving for x or y. And when we're solving for x and y, we actually take that value for y and plug it into the other equation. So for example, if I took this equation here, I would solve for y. Y equals negative 5x minus 1. This is what y equals. If I were solving this by the substitution method, I would take what y equals and plug it in right there for where y is. So I would go 2x minus 4, and then y. Y is negative 5x minus 1, and that should equal negative 7. So 2x distribute, so I get plus 20x plus 4 is equal to negative 7. I get 22x, and I'm going to subtract 4, so that's going to be equal to negative 11. And then I'm going to divide both sides by 22, and I'm going to get x equals negative 11, or 11 over 22, which reduces to negative 1/2. And then what I would do is, this is x, so I'm going to plug it back into one of the equations. I'm going to just plug it in here. So y is equal to negative 5 times negative 1/2 minus 1. So that's 5 halves minus 1. That's going to be 2 over 2. 5 minus 2 is 3. So 3 halves. So that means that my intersection point is negative 1/2, comma, 3 halves. And completely fine to get a fraction, but you definitely should plug it back in to check your answer. And the one last thing that I wanted to say is that if I hadn't solved this equation by the substitution method, I would have multiplied this bottom equation by 4. And in doing that, like on the other problem, right, I would have gotten 2x minus 4y equals negative 7. That didn't change. And then 20x plus 4y equals negative 4. And see how the 4y's would actually cancel? That's what the elimination method is all about. So that's why you would actually use the elimination method. So anyway, thanks for watching. Do your homework, and I hope this helped you in some way.